Hi everyone. Today we're going to look at paper 1 question. This question is from the thermal properties of matter. So this question is 2007 paper 1 question 16, and let's read the question first. The question states that a 2 kg mass of copper is heated for 40 seconds by a heater that produces 100 joules per second. The specific heat capacity of the copper is 400 joules per kg per Kelvin. So the question is, what is the rise in temperature? So obviously we know that this question is from the thermal properties of matter, so we will need to apply the concept of thermal properties. But on top of that, we also need to know that there's actually a transfer of thermal energy happening between two entities. The first entity is the energy that is produced by the heater that is being transferred to the copper. So the energy produced by the heater is equal to the energy absorbed by the copper. So this equation also tells you that energy is transferred perfectly without any loss. So it's actually a concept on the principle of conservation of energy also. So first of all, let's look at the energy produced by the heater. So when we look at this 100 joules per second, it actually tells you that the heater is producing power, because joules per second is actually, joules is actually energy, per second is actually time. So energy per time is power. So if you want to find the energy produced, then you have to use the formula energy is equal to power times time. So we know that the power is 100 joules per second, and we know the time applied is 40 seconds. So the energy supplied by the heater is 4000 joules through the calculation. So the next thing we also are aware of is, of course, the other side of the equation, which is the energy absorbed by the copper to rise in temperature. So this one we need to apply the heat capacity formula. In this case, it's a specific heat capacity formula, which is mc delta theta, right? So where m is the mass of the copper, c is the specific heat capacity, and delta theta is the change in temperature, which is the unknown that we need to find. So from there we know that the mass is 2, the specific heat capacity is 400, so the equation becomes 800 times delta theta. So when we put these two equations together, which means that we are putting the energy produced by the heater and the energy absorbed by the copper together, we have 800 times delta theta equal to 4000. So working out this, we get 5 degrees or 5 Kelvin, which have the same change in temperature. So from here we see that the answer is A.